learning all about the factoring. Woo! Alright, so we're going to start off today with factoring out the GCF, or another way to say GCF is the greatest common factor. Ta-da! The greatest common factor is the GCF. So we're going to start with a smaller one. 9m cubed minus 9m squared. So how you're going to do this is you take the two numbers or variables that are similar. In this one it would be 9, and m, not cubed because there's only one cube, but squared because there is a square within a cube. So it would be 9m squared. And so basically you've just taken out this whole one. So you would cross that out and it would just become a 1. So you've gotten rid of the 9, put that here. And you've gotten rid of the m squared, so it would just become an m. So now you have 9m squared, and then in parentheses it would be m minus 1. And now you factored out 1 GCF, and you are left with a binomial. Now, let's try one that's a little bit, it's still easy, but different. So here we have 2 of the same, a plus squared and a plus squared. So you would separate them from the other two numbers and just make it a plus squared in parentheses. Now you've taken care of these two. And all you have left is a 3 and a negative 5. So you would just put them here. 3 minus 5. It appears I've missed out on a letter. Oh, that's right. There goes an A here, because you can't just have 3 minus 5, that would create negative 2. So you'd have 3 minus 5, A. Close that in brackets, and you have your GCF. Alright, now we're going to move on to factoring trinomials with A minus 1. To factoring trinomials with a equals 1. So we have a simple little procedure here. We have n squared plus 4n minus 12. So we're going to do something called the house method, where you build a little roof and you see what this and this multiply out to be. Since this is just a 1 and you only have a negative 12 here, it multiplies out to be negative 12. Now you're going to build the chimney and make all the factors you need that makes negative 12. We could do negative 6 and 4. No, sorry, lied there. Negative 6 and 2. Negative 2 and 6. Negative 1 and 12. Or 1 and negative 12. And now you use the numbers in the chimney to see what equals out to be a positive 4. Could it be negative 6 and a positive 2? No, because that would then be a negative 4, so we're going to cross that one out. Is it going to be a positive 6 minus 2? Yay! That's going to be the answer. Because 6 minus 2 equals positive 4. Okay, so what you're going to do now is you're going to break up the n squared to just be n times n. Put them in parentheses. Now, when you multiply these, when you factor them, it's going to become n squared. Now you want to create your negative 12, and we decided that we're going to use positive 6 and negative 2, so we're going to do negative 2 and plus 6. It doesn't matter which order you put them in, as long as you get n squared plus 4n minus 12. And that's how you factor trinomials. Now we're going to be working when a is greater than 1. It is exactly like we did in the last part when a was equal to 1, except that now we have an extra element, 3 or 4 or 2 or 5 or 90 for that matter. It can be any number in this section right here as long as it is before n squared.
Woo!
So this one is a little bit more guessing check. When you have a number like 3, you are always going to keep 3 before n. just because it's a prime number. Now with other numbers, it could get a little bit more tricky, but for the purposes of this one, it's going to remain 3. Now we have the 4 here, and we need two numbers that are going to multiply into 4, but are going to add up to 8. So you might think, well, that's impossible. The only things that could get to 4 are 1 and 4, which would add up to 5, or 2 and 2, which adds up to 4. But we have this extra number here, 3, so when you multiply it out, you're somehow going to get to the number 8. So you're lucky here, since we have a positive, you know that both numbers are going to be negative.
This might be the cutest thing I've ever seen.
Because this here is going to be negative, so you know that in order to get to get a positive, you need two negatives, and that's lucky. So put this in parentheses. You're going to need the n over here in order to get the n squared. Negative again. And let's try 2 and 2. Minus 2, minus 2.
I think I just found the
Now
problem.
you're going to do little steps down.
Oh, shit.
And to see... to them. Alright. So I'm just going to be a negative 2n because you're
I just
factoring
answered my own
this
question.
And then you go down
Kid
here.
moved his piano back and
You're
slammed
going to
his
have a
thing
negative
back
6 because negative 2
question
times
is,
3
can we
equals
fix that?
6. So it's going to be negative 6n. Add them together, and what do you get? Negative 8n. There you go.
Ta-da! So factoring by grouping is my favorite type of factoring method. It's easy, personally I think it's kind of fun to do, and it's just putting things into different groups. So I already separated this one out for you. So as you can see, the 2x minus xy has one thing in common, these x's. So we're going to do as we have with all the others and take out the GCF, which in this one is the x, and we're going to put the 2, as we see here, and the negative, because that doesn't separate out, and the y. Now we have x, 2 minus y. And now on this one, we're going to take the positive, because here it has not gone to anything. So positive, and the GCF here is the y, and the y. And, alright, so we're going to take the y here, as we have with the x, and take the 2, but because we already took out a positive, it's going to become a negative, and make that another y because there was a square here. There we go. Now, what do you notice is common here? I'll give you a hint. It rhymes with shmoo kinus tie. That's right, it's the 2 minus y. And we're going to put that in parentheses. Now that that is the new greatest common factor, we're going to cross those out. And all we have left is x plus y. And there we go. Factor by grouping. That's all you got to do. Now, let's go on to this one. This one's a little bit different, but kind of the same. The only difference here is that you can, here's the secret, rearrange. If it doesn't work out to your benefit, then you can rearrange them. 2x squared plus 3y, they have nothing in common. But 2x squared and x squared y do. So you're going to take that over there. Oh, wait. Sorry about that. You're going to take that over there. And you're going to take that over there. Rewrite it. So now you have 2x squared plus x squared y plus 3y minus 6. Now you have it rewritten. So you're going to take the GCF as we have before. Here it's going to be x squared. Now we have left over a 2 and a y. So it's going to be 2 plus y. And here our greatest common factor is the 3. And we're going to take the positive here and 3 there. So plus 3. Now we have y plus 2. Oh, wait. Yes, okay. And sorry about that. We have 2 plus y
I'm not following you.
and x squared plus 3.
I mean,
And all right, there we go. Now, the difference here is that we see y plus 2 and 2 plus y. They mean the exact same thing. The only difference is their order.
1 plus 2.
And that concludes that.
Okay, so remember what I said before about the other one being my favorite? That one I certainly like a whole lot, but this one definitely, it's really good because it's super easy and great to understand. It's called the factoring difference of perfect squares. Basically what you do is exactly what the name is calling it. 36 is a perfect square, right? 6 times 6. 4, perfect square. 2 times 2, and 25, all the same, 5 times 5. We'll start with this one. X squared minus 36. X squared, perfect square. X, 6, 6. X, 6. Now, how, my friends, do you get the negative?
I don't know.
That's right. You multiply and negative times a positive. So what are we going to do here? Negative
And a positive.
minus 6, x plus 6. X squared minus 36. Now, in case you don't believe me, we will factor it back in. X times x equals x squared. X times 6, oh, that's not squared. X times positive 6 equals plus 6x minus x squared minus 6x, and 6 times 6 equals negative 36. How about that? We're going to factor these out because a plus and minus cancel each other out. And what are we left with, my friends?
X squared minus 36.
That easy. Now let's do it with the rest of them. X, what do we have? A 2 and a 2 and a minus, so x minus 2. And what's the next one going to be, Becky?
I don't know.
Well, let's try x
Plus?
2. There you go. You have another one, and the final one. X plus 5 and x minus 5. That's it. That's how you factor the difference of perfect squares. Now, hold on. Before it trips you up, let's show you one that cannot work. X squared plus 36.
Dun, dun, dun.
It's the doomsday one. They will put it on tests, and they will put it on quizzes, and they will put it everywhere to say, hey kids, what's the difference of this perfect square? What's the thing that catches you up here? That plus sign certainly does not look like a difference. And if you did x minus 6 and x minus 6, that's going to give you more numbers than you want, because let's go back to this one. If you had 2, if this was also a minus, and you went to that, then this would then become a minus. And now you have negative 12x. And x squared minus 12x minus 36, actually that would be a plus 36 now, wouldn't it? Because a minus times minus is a plus, is certainly not that. So, if you see a plus, and it is in this, and they tell you it is that, it is not. Do not trip yourself up. This is what it is. Find the negative, and you've got a difference of perfect squares. Alright, let's move on to the next one. So, remember that thing I just now said not to do because it kind of gives you a that? Well, this is exactly what we're going to do now with factoring perfect square trinomials. Before they were just binomials, but now that we have tried, we need that third number in there. So, what did I say last time? You didn't need
I don't know.
a negative? Becky, did you need negative or positive in the last one? It rhymes with a schmegative.
A negative.
Negative, that's right. You needed a negative to just factor a perfect square, but now with the perfect square trinomials, you're going to need something one up, a positive. So, to get the positive, we're going to do exactly what we did last time. We have a x plus 6 and an x blank 6. Now, in order to get the negative, we're going to need the negative here, but to get the positive, and that is how you get the x plus 6 and x plus 6. This will add up to the 12x, and x plus 6, x plus 6. This could also be put into x plus 6 squared, because they're the exact same thing. Alright, so we've changed rooms. I've gotten myself a partner.
We've got a wild Ben going on
We've got a
here.
wild Ben going on here because guess what? We're learning something totally crazily new. Except not really, it's a joke. I just got kicked out of the drama studio. What's happening here is now we're gonna go with factoring quadratic form. Yeah!
Dun dun dun.
Okay, so factoring quadratic forms. Ben, what's the difference between factoring and quadratic form? Like, what do we got different here?
Jesus, Cameron, I don't know.
Well, Ben, I see a 4 as opposed to just a, what was it before? An x.
Whoa.
And so now, as you can see, it used to be x squared plus 14x plus 40, but we have made it bigger because I dropped my pen.
Oh no.
Because the difference here is that quadratic form has more. As long as this x is double whatever this x is, it's going to be in quadratic form, right, Ben?
I guess so.
Oh my stars!
Oh
That's
my
crazy.
stars.
Okay, so we're just gonna factor this out.
Do you? I don't know.
It's the same as factoring out a regular one, except now you have a kind of bigger x. Let's see here. As we used the house method before, we're going to use it again. We have a 40 here. We're gonna build ourselves a chimney. And x times 40 equals what then?
40x.
No, just 40. But thank you.
X times 40 equals.
Well, no, just 1 times 40. Sorry.
Oh, okay.
Sorry if you misunderstood that. 1 times 40 equals
40.
40. So what did we do?
Multiplication.
We got 20 times 2 equals 40. But could 20 minus 2 equal 14? No.
Mm.
Well, we could try 10 and 4.
That
sounds like
works.
a breadwinner to me. 10 times 4 equals, or sorry, 10 plus 4 equals the big magic number 14. So we're gonna move on from there. We got x. Now that it's x to the 4th, we're gonna make it x squared in this one. We're gonna make it x squared in this one so that when you multiply them out, it's going to be x to the 4th. And because this is a positive and this is a positive, they're both going to be positive, making it easy here. And now we got 2 numbers. Ben, what's the first number going to be?
10.
And what's the second number going to be? You got it. That looks like a 9. Alright. And your final answer is going to be x squared plus 10, x squared plus 4. There's something wrong here. It's not done factoring.
What?
Oh wait, no, just
Yeah,
kidding.
it's
It is
done.
because what did we learn here? That's
Yeah,
positive,
factor
not
positive.
negative. If this were a negative, then what would you do, Ben?
Factor it further.
You would factor it further because of the factoring difference of perfect squares. But this is not a perfect square. It is not a difference. I mean, it's a perfect square, but it's not a difference. So we're going to leave it as is. It's wonderful. It's beauteous. We're moving on to the next one. To wrap this class up, we're going to do what is the most important step of all. Factoring completely. Completely.
Whoa.
It's completely and
Completely.
utterly important. Back when we learned at the beginning of this class,
GCF.
the GCF.
Good.
1. GCF.
Good.
Always. GCF is always the first thing you do.
We'll call it that now.
So what do we have here? We have a 6, and we have a 6 here. We have an x over here. I don't see an x, so x is not greatest common factor. We have a y. Is there a y over here? We do. So we're going to take the 6. 6 over here. We're going to take the y. Ow! Ow! No more 6y. What does that become then?
1.
1.
We know. That's what's
Okay, what do we have? Now we're gonna make a parentheses. We have an x to the fourth. 1. Good job, Ben. Good job. Golden sticker. Okay. We're done. Are we done here, Ben?
It doesn't look very complete, though.
It doesn't look complete. That's right, because of 2 other lessons we've learned today. Next one.
Shouldn't have skipped those
Factor
classes.
completely. Because we have right here a quadratic form. We have a 4 right there. That can be factored down because what is the square root of 4?
2.
2 squared. And remember the factoring of the difference of the perfect squares? That's it! Right here. I'm going to do x squared plus 1 and an x squared, or x squared minus 1, parentheses, carry down the 6y because that just never leaves your side. Love the 6y. Never goes away.
But teach,
Yeah?
it doesn't look complete yet.
It's not complete yet. What do you mean?
It's almost as if there's another ninth side.
There's another perfect square in here? Another difference? It's not that one because that's an addition
That's a
sign.
plus.
So
Come.
it's got to be that one.
Yeah.
That's right. So now we're going to bring this down. X plus 1. X parentheses. Carry down this one because it has not changed. X squared plus 1. And bring down your love. 6y.
That was pretty
Ta-da!
That's it. You can't factor it down anymore. You can't GCF anything else. Now you have factoring completely. Unfortunately, students, that's all we've got for today, and that's all you're going to learn about factoring for
Ever.
right now, at least.
Oh.
I hope you all had a fun day. This session has been a little different than a lot of people usually do them, but good job, Ben. Good job, Becky. Good job, students. Have a
job,
good one.
Adios. Okay. I'm just gonna keep recording. The tears are rolling down my cheeks.